Hey everybody, just making a video to walk you through the instructions on Project 2. So if we pull up the PDF, you can see all the instructions here. Let's see, the first part is asking you to create a least squares regression equation for the data set that's given. Right here, it says calculate the linear regression equation. And the linear regression equation, it's really just y equals mx plus b. It's often given with different letters, and usually Greek letters, but that's basically all a linear regression equation is. You need to calculate a slope, like we've done in previous math classes, and a y-intercept. And they're the slope and y-intercept that most closely fit those data points. It gives us the least squares error for these. Okay, so let's do that. Here, I'll open up this link, show you what that looks like. While that loads here, this is the data set you want. You want to download this data set. So you can download it to your computer, let's see, or you can type it in because it's not too many. But I clicked on the data set up here and it just automatically downloaded onto my computer. Okay, so that's the data set. We're going to copy and paste this into this calculator. The x values go on the left, the y values go on the right. Now the x values are always supposed to be the independent variable, the one that's not impacting, the one that's not being changed by another variable. The independent variable is almost always time when it's given, unless you're in like some sort of quantum physics class with something I don't understand about how time is changed by gravity or something crazy like that. Oh, that doesn't look good. Okay, so I copy and paste my y values, and then I don't want to give away the answer so that people can just type it in. You click calculate the regression equation, and the slope, you replace this with whatever your slope is. Let's say it was 2.1, and then you replace this with whatever they give you for the y-intercept. Let's say it was 1900 for the y-intercept. Okay, that's it for the first part. That's your least squares regression equation. They want you to use the regression equation. How old is the man in 1945? So as you recall in that last screen, we plugged in 1945 for our x variable. So if this is my regression equation, to answer that question, I'm plugging in 1945 in for my x variable. And then you solve for y, and that's your prediction. Okay. How old do we predict a typical man to be when they get married in 2000? Same thing. You plug in 2000 in for x. And then this is your opinion. Do you think these are likely or not? Likely predictions. Remember, this is y is the average age of a man getting married at the corresponding year. And that's it. It looks like that's it for 1.1, 1.2. Part 2, 2.1, 2.2, and 2.3. Here, I'll help with 2.1, 2.2. These are permutation combination problems, like we saw in our statistics unit. For these ones, you have to decide which formula to use, and I'll help you with the ideas behind them. The permutation formula is n choose r. That's calculated by using n factorial over n minus r factorial. And once you calculate that, you have the number of different options for this sort of arrangement. How many different ways you can arrange n objects into groups of size r. But then there's also a combination formula, and it has an n and an r in it, and it looks really similar. Slight difference. There's an r factorial on bottom. The difference is a permutation will calculate how many different ways you can arrange objects if the order matters. So you got 5 kids in a class. You want to rearrange, you want to put them in, here, actually, let's do something else. Let's say you've got 20 kids in a class, and you want to put them in groups of 5 to go down to lunch. If it's going to lunch, the order matters because if they're little kids, they want to be first. So the different ways a teacher rearranges those groups is important because he or she wants to give those kids all a chance to be first at some point during the year. So the teacher is going to calculate how many different ways. It's 20 factorial over 20 minus 5 factorial. The order matters, so I'm choosing the permutation formula in that case. So remember to do this. It's 20 factorial means 20 times 19 times 18 times 17 times 16. You can do that all the way down to times 1. Or you could make your life easier. Stop and put the factorial symbol back at 15 because look, 20 minus 5 gives you 15 in the denominator. Those can cancel out. So this is all you need to punch in your calculator for this particular permutation problem. You wouldn't use 20 and 5 into the combination formula in that situation because we said the order mattered. The order matters in which you send those kids down to lunch because they want to be first. Being last stinks for some reason with kids. An example of when the order doesn't matter would be like if you need to send 3 representatives of like there's 15 employees for a company, 3 representatives need to go to represent to go talk to the union maybe at your company, right? 15 is your N, that's the number of people you're picking from. Your group is a size 3, and the order doesn't matter because if you pick Joe and then Jessica and then Richard, doesn't matter if you pick Richard, Jessica, Joe, right? If you switch up that order, it's still the same group. Order does not matter. So you use either one of those 2 formulas when you're doing part 2.1 and 2.2. You got to decide which one is right. 2.3. I feel like I just worked this out with a student the other day. Man, it feels familiar. I think I might have a video for 2.3, but here, just in case I don't, you've got 5 variables, x1, x2, x3, x4, x5. We don't know what the numbers are going to be. This would be like in a programming situation. You want to make every possible grouping of the variables. You could have x1, x2, you could have x1, x3, you could have x1, x2, x4, x5, but it says the order does not matter. So how many possible groups could you make with those 5 variables? So they told us the order doesn't matter. So that hints at combination. So we have 5 variables we're picking from. How many groups can we make of size 1? You want to add that to how many groups you can make that have 2 variables in them. And then how many groups can you make that have 3 variables in them? x1, x2, x3, or maybe x1, x2, x4, or x1, x2, x5. How many groups can you have? 4? And then there's one last option. You know what this should probably be. You shouldn't have to use the formula for this one, right? It's supposed to be plus. If you're trying to find out how many groups you can make that have 5 variables in them when the order doesn't matter, there's just one group, right, where you list all the variables out. The variables don't repeat. So for 2.3, pretty much giving it away what you got to do. You got to make that calculation. Okay, 3.1 and 3.2. Let me see what I can do without giving away the answers here. 3.1 is calculating expected value. I think I can come up with an example. So let's say a company determines. Okay, apparently I can't write on my computer anymore. There's a 3% chance they lose $1,000 on an investment. There's a 50% chance they gain $800 and a 20% chance they break even. They lose $0. So what's the expected value? The expected value is found by taking the decimal form of that percentage, so the probability, times the amount. And this one I'm going to make it a negative 1,000 because I'm talking about the expected value for the company's investment. The company loses $1,000 with the first option. Okay. Now this next one I'm going to make positive. We have a 50% chance that we gain $800. And then there's a, you don't really have to write this one out because it's going to be times 0, but there's a 20% chance that we break even, that we have $0. So that's what you compute to find out the expected value of that particular investment. There's just an extra option on this one. It's the same idea on 3.1. 3.2, I think we're going to make a separate video because that one's a little bit longer. That one's from the exam P, from the practice exam P, which is an exam they give to actuaries when they first start going down that route. So it's more challenging than what we've done in class, but I can help you through it. So I'll make a video for that.